Hi everyone, I'm Fauzan and I'm here to present to you my final year project titled Privacy-Preserving Keyword Search on Encrypted Database. Before we get into the presentation, I just want to define a key terminology here. Encryption is a way to hide information by changing the original data to some secret text. So in this project, we mainly talk about how to use encryption to hide our search data from the search engine provider. Let's start with the background as shown in the slide number 2. According to Forrester research done in 2016, 93% of web traffic comes from search engine. And this means that a lot of data are collected by search engine providers such as Google, Bing, and many others for their own purpose. This purpose can be personalized recommendation, suggestions, or ads. And this poses a very big privacy problem. While there are current solutions available such as DuckDuckGo, Quant, or SearX, there is still a problem with the current solution. And that is, the privacy is privacy by trust instead of by design. This means that we have to trust that they don't use our data, but we never actually know what they actually do with our data. Next, let's go to previous studies in slide number 3. From previous studies, researchers have found a way to hide our search data, and that is by a special encryption scheme. There are many types of this encryption, such as property-preserving, identity-based, and searchable symmetric encryption. They have common goals, which is to minimize information leak to the server and optimize the performance of the search. Each of these methods have their own pros and cons, but we chose one of the best methods, which is searchable symmetric encryption. Moving forward to slide number 4, we have the research gap. So if there is already a method found previously, what are we doing? The research gap is that there is no client-server model for this searchable encryption scheme. The algorithm is already found, but no one has developed the real application for this. And this kind of model is important as it will be able to demonstrate the feasibility of searchable encryption in real application and show that it is possible to be applied to large-scale search engine like Google. So our objective, as can be seen in slide number 5, is to create an implementation of searchable encryption as a web application. The web application must be able to be opened by any modern browser such as Chrome, Firefox, or Microsoft Edge and not require any additional installation. This is important because when you search on Google, you don't want to install any additional package. The implementation of SSE encryption schemes will be based on Collation code library, which is written in Java. So our application will also be written in Java. So you can see the reference list in the last slide, and this marks the end of my presentation. Thank you for your attention and see you next time.